you
It's
said?
it's up to you guys. I could show you the breakdown of the simulation first if you think that that informs the discussion. It's actually not that hard. I mean, it's a lot of work, but it's not that hard to explain, actually.
I don't know, Jeff. It's your call, I guess.
I'm good to start with the. Why don't we start with where you're at with the module Z, and I feel like there will be like the flow of conversation will basically say, you know, where we start with this, what we want to get across in this article. Kai just had a conviction voting article come out today or yesterday. I'm guessing you haven't seen it yet, Z, but yeah, I just want to be able to leverage what's used in that, and also, yeah, it was just published on Giveth this morning, I think.
Oh,
I literally, I don't know if have I even seen this one. Let's see.
It's called. I'll
You
post
looked
the
at it
link.
a long time ago. You looked at it a long time ago.
Yeah.
So I probably gave some feedback, and okay, well, I'll
you did
later.
It's kind of about the concept of continuous voting, and I want the article that I'm writing to be more about the component of conviction voting.
Gotcha.
So we're tying it in closely with what we're doing, and you know, the simulations and the modeling.
So then let me
using the ideas explored there.
So that makes sense then for me to. Oh God, it like here we go. Okay, so just to sort of give you a basis. So I wasn't attacking this from the perspective of making the module. I am attacking it from the perspective of getting a running model, which means that like a module is a lot of work separate from getting a running model, because what you'll see is that a relatively correctly written, just sort of like jammed out CAD model has, you know, a little of upfront, you know, utilities not necessarily need to be in it, a bunch of initial condition construction, which is just there because it has to be to run a simulation. And what I ended up doing, and I'm going to jump, I've been talking to Marcus about how best to explain these things, to the part where I actually have the partial state updates. So actually, logically, the description of this model is I have a policy that generates random processes to evolve the network. This is the arrival of new participants, the suggestion of new policies, and the arrival of new funds. Those are all state-dependent random processes, meaning they're not completely random. Like, you're not going to get new funds in large quantities if the sentiment's low, and sentiment is one of the states. But it's still just primarily a random policy. This is stuff that's happening. And then we have the updates to the states as a function of those policies. And since you guys have sort of seen the way CAD breaks things out, you'll see a recurrence here. There are actually 4 sub-steps, each of which is decomposed as sort of decision-making and then consequence of decision-making. So here, because some proposals have been passed, we check progress. It means basically I'm going to flip a random variable to see whether the project got completed, and the rate of completion is going to depend on a couple other internal variables, but ultimately this is still just like I would say the wrapping, because it's not the conviction voting, it's the stuff around it. But we talked about this before. There's sort of like not full resolution logic for the rest of the world, right? So a lot of random variables. But when a project is completed, you see increases in sentiment. In general, sentiment decays if you're not completing projects. So, you know, if you tune down the rate at which projects are completed, the sentiment falls because there's like more time for it to decay before it's bumped up from the fact that something's completed. And then we have, this is the sort of one of the main blocks for conviction voting. It's the trigger functions. The trigger functions are basically just the logic that we talked about. I have the function up at the top, so I'll show you. But basically, if any particular proposal has more conviction than the trigger function for that proposal, like it has a threshold, then it, like the neuron fires, the proposal gets passed, it releases. There is I put a min time block on it, so you can't release something in less than 7 days in my example, unless, or even if it has enough conviction. So you can't just like put a proposal up and pass it without people seeing it. And in my mind, this just means like you can't get away with passing something before there's time for, you know, people to, you know, look at it if they want to. And even though you can't necessarily block something in the negative voting sense. It does allow for the normative feedback loops. So if you're putting something up and it's sort of like people feel like it's sort of against the spirit of that particular community or that commons, that you're not going to like get it past them. It'll be like, okay, well, you're doing that, maybe it's whatever. Like I'm not going to go into the sort of like politics of it, but it's there in part to help make sure that the normative feedback loops aren't being bypassed.
And that 7 days was needed. That's just a parameter.
Yeah. This is just a variable that I picked. It can be 7 days. There's also a thing I didn't lay in, which I would probably, which is a minimum amount of funds to request, because the trigger functions are dependent on how much funds you ask for. It would be a little weird if people were like spamming it with like really tiny asks that were really easy to pass. So you would have to be like, okay, well, a minimum ask is like, $5,000 or something, or whatever. But like it would have to be tuned in such a way that like you wouldn't have people just like bleeding it out in really tiny quantities by picking requests that were small enough for them to pass themselves. You know what I mean?
Cool. Yep.
But those are kind of like edge case, like things that you definitely need to be there for what I would say is the engineering work. I'm really, though, like this goal for getting this running was, we talked about this before, like you have to get a model running before you can get it iterated up to the point where it has all of those details. So like the first running model is actually a really big milestone, but there's a lot of work between the first running model and say the model that you use for final design sign off, and also the model that you use for the module. And I would argue that the model for the design sign off is still before the model for the module, because you would literally be wrapping up the model for the design sign off into a slightly more generalized, but also like you have to put extra documentation around it and explain how to use things. And so I think of it as being like there's a really critical first milestone to show that this makes sense and this works, which is what I have now. And that, but I wrote it in like I wrote it in like 2.5 days. So like the fact that I got it up and running and it works how it was expected to work is mostly a byproduct of the fact that I already knew how the algorithm worked, because I designed it based on PhD work. So it was nice to see it doing what it was supposed to do, but there's a lot of work between what I have, which I think is good for narrative and sort of quick pictures and little videos, and something that would be right for like, formal sign off for something that would become the decision process in potentially allocating large amounts of funds.
Cool.
That makes sense. That's the sort of description. The last block here is the participants' decisions. And this is actually the place where I can update it to work like the bonding curve relatively easily. I was looking at it because as it stands, all I really did was say there's the last block is just updating the participants' decisions. So they decide, to increase or decrease their holdings and cast their votes. And behind the scenes, they have affinities, which I can also make time varying. The nice thing about CAD/CAD is like once you have a working thing, it's remarkably easy to change things a little bit and keep them and tune them and keep them running. So in this case, we had sort of the supply of tokens rising over time, which isn't surprising. Actually, initially it's going down because nothing has been passed. The system had to kind of get up and running before it was generating positive sentiment, because positive sentiment gives rise to like, proposals being proposals being passed gives rise to positive sentiment, which gives rise to basically individual participants are happy when their proposals that they're supporting actually get passed and completed. But it takes a little time before that starts happening because it doesn't start with anything in the works.
Is sentiment a generic measurement, or is that tokens allocated towards a specific
sentiment is an abstracted hidden state that in the real world we would not be able to measure directly. And in the model, it's just there to represent the in the individual. So there's two sentiment variables in this model. One is at the level of the individual participant, and one is at the level of the general, like outside population. Okay. This plot isn't sentiment though, this is supply. Sentiment is tracked in this system as a 0-1 variable, which is basically there to serve. It has to serve the role of a sort of a value of a hidden state in the real world, but it's a really important pathway. Go ahead.
When you say supply, do you mean token supply?
Yes, because you're doing a voting with a token. So the token supply is actually a peer trigger function, but it increases because people are going and getting it. So there's a proxy for essentially the bonding curve logic being filled in here. And right now it just doesn't, it doesn't have an elastic price, or even really, this current version of the model that I've written does not worry about why or what it would cost you to increase your supply as an individual agent. It says, look, I want more, so I want a marginal amount more, and assumes that you're willing to bear the cost of that marginal amount more. But then everyone's doing that. So you see the supply actually goes up over the course, because there are new participants arriving. There are people, because the sentiments are high, because things are happening and successfully, they're wanting more. So I can make conditions where this tanks instead of goes up. But most likely, I will incorporate at least the basics of the augmented bonding curve logic into this in the not too distant future, because I think it will make for what it will essentially be a storytelling level emulation of the actual system we're building.
Yeah, because the supply will definitely look very different.
It should
with the hatch sale percentage. But it doesn't matter,
that'll affect the token distributions. So I mean, but that goes back to the point that I wasn't yet trying to make I can even change the initial distribution. So I generated them randomly. So I used this distribution for the token holdings, which is still a tail distribution for a reason. But like if we did a hatch sale thing in here, we would basically say, okay, well, let's draw two sets of random variables, one for the distribution of the hatch, which will be much further up, and one for the distribution. It'll be like bimodal in that case. But again, this is all just in the setup. So like in the top here, you can set things up. And I don't want to run super long. So let me jump down to where I made plots, because I think that really explains what this does. So I'll go back up to the top of the plots. So just to give you a sense of the CAD stuff, though. So what happens? Well, CAD throws out this, I can do 25. I think it says running. So. Oh, because I added all the states. So now this thing is got a lot more stuff in it, because I've been adding things. So you don't need to worry about it. The nons are there for a reason. I put them there actually for plotting reasons. Anyway, so this is just the this is a snapshot of what's in the data frame. It's just like a table structure. We've got plots of supply and sentiment and funds. This is the high level view. And here you can see funds are coming in and being expended, but it's going up overall on average. It's a little strong. I can tune it down. It's again, the thing that this relates to is the rate at which we would expect funds to come in as a function of sentiment. And so if you turn it down enough, then this goes the other way. But one of the main reasons why this particular plot is going up so much is because as it's currently tuned, the sentiment stays really high. So the way that I set it up, if this sentiment were to fall and not just be so close to 1, almost certainly this wouldn't be accumulating so much. If that makes sense. Cool. Okay, so some plotting utilities here. This is just basically data science work almost. I'm just doing data munging. It's a bunch of reorganizing the results, because the CAD model throws out that data frame with the nested graph, and a lot of data is in that sort of. It's almost like having a small graph database in memory, the network X data set. So I'm like the network X state variables. So I'm basically plucking the data out of the graph object using these lambdas and putting them in more traditional, records in the. They become sort of like nest tables with nested values, because I'm putting numpy arrays in elements of tables, and so all of this is just collecting up the data from the simulations. Because there are 4 sub-steps per time step, I just grabbed the last one to make this a little simpler, and get things like, these are my randomly generated affinities. I sent this in the thing, but basically people aren't behaving homogeneously. I've made everybody's preferences random, and so they vote for things that they actually prefer based on this underlying preference matrix. So this is the participants on the left, and this is the proposals on the right. And so the only thing is that I didn't yet encode any social crossover effects where people support things because they're basically, this graph that I have underlying this is proposal by participant, but I can actually also layer in proposal by proposal so that certain proposals are conflicting, and if one passes, that the other ones who are for the same thing sort of lose their votes because no one wants both. And then I can also put participant by participant edges that represent sort of mutual influence, also relatively easily because of the construct. And I would expect both of those things to be in there for their actual engineering work, even though they're not in here for the initial sort of demonstration. Does that make sense?
Yeah.
So like social network effects in the participant by participant, and sort of counter, like sort of competition graph, conflict graph between the proposals, so that a proposal that is passed could render another proposal extremely unlikely to pass, even though it doesn't technically remove it from the list. It would be implying that, you know, it doesn't make sense to have both.
So when you say proposal versus proposal, so for example, there's two proposals trying to do the same thing. One passes, the other obviously does not. So all votes.
It doesn't. It's not that we would. So what I'm trying to say here is I'm putting that in the facts about the world layer, not in the facts about the module layer. In other words, if to imagine two proposals that are very similar, both charging up and getting close to passing, but it's well understood that like both of them probably aren't needed, then technically you could still pass both, because if there's enough conviction to pass the second one, even after the first one passes, it just means that the community is choosing to de-risk something by funding two separate initiatives on the same topic, which is not, there's nothing wrong with that, because technically we're not guaranteed, this is just funding, it's not the outcome. So like you could fund two projects to do almost exactly the same thing, and that's like a parallelization. It's just that when I would model this, it would basically make it so the likelihood of that is much lower if there's a notion of conflict.
Well, and especially if there's a giveth layer, it's not like the money's lost. The money can be refunded by a reviewer who has the best interests at heart of the team.
Yeah, so I mean, again, this is mostly just, I'm talking to you guys about the perspective from what I have here versus where we're going. And so things like we will need proposal to proposal underlying graphs and participant to participant underlying graphs in order to represent the problem. But also to be clear that a big chunk of this is actually computational social science. The engineering part is just using the computational social science layer and just changing the fuck out of it so that you can say, well, what if it's like this? What if it's like that? What if it's like that? But you still need a pretty good quantitative social science layer to use as the basis for running those experiments and tests.
And what is the point of the participant versus participant underlying graph, or participant on participant?
God, because participants are just, I don't know, I guess this is just not common knowledge. So if you do a study of group decision making, the actual social influence fucks everything up. People's influence on each other basically makes their private signals harder to extract. So if you believe that the private signals of the participants in a system like this have the information that you need, but then you let them basically gossip with each other, the gossiping process basically completely screws up the underlying signal extraction. So from a signal processing level, it actually makes, well, I mean, I can't necessarily say it screws it up. It makes the answer very different. And so understanding that that is at a signal processing level having a very large effect, it wouldn't make sense to ignore it. You need to be able to like
build that into the model.
Yeah, and because this is a graph data structure, it's not that hard. But this is a lot of stuff that's not going to be represented in the in any smart contracts. It's a lot of the difficulty is in the representation of the world that you use in order to validate and test the smart contracts, which again, technically speaking, the smart contract is going to be able to do exactly what it's supposed to be able to do. The real question is whether it serves the needs of the people, and you need to have notions of what that means. And here that's going to mean things like, you know, the decisions are aligned, you know, with the affinities, for example, that like people's actually actual preferences, private signal preferences are being expressed in a meaningful way. We're never going to be able to say this was the right answer and this was the wrong one, because there's many different ways of aggregating up those low-level preferences. But if you combine the sort of method of building out a set of underlying preferences and then the set of outcomes, you can measure various sort of social, basically social choice utilities. And I generally advocate for making more than one and being like, here's a couple different well-defined social choice utilities, and hey, look, it does pretty well on all of them, rather than saying, hey, look, I optimized it for one of them.
Cool. I like that. Awesome. I got some good notes on that diagram. What else we got?
So, and I'm going to try to go a little quicker because I really want to give you the floor before we run out of time. So actually, I'll make a really important point. The thing that's really hard and is awesome about CAD is the whole, the evolution in time is where all the interesting stuff is happening. It's not necessarily about any one decision. It's about how the system is sustainable, right? It's regenerative. So here we see the 7 candidate proposals at the beginning. You pass some of them, they become active, and when the active proposals are completed, they become completed, and you see accumulating completed projects over time. But you actually see a continued, like there are candidates there pretty much continuously because new ones are arriving. So what we're really trying to do is convert candidates into active and active into completed and accumulate output, right? We want material output from this community, not just funding. That's the catch with a lot of the funding, DAOs, is that they're sub-optimized in the sense that they're designed to fund things. They're not actually designed to fund things that produce things to fund things in the future. Like, you don't close the loop. And I have the other diagram that I showed you before, which I'm actually tempted to snap into here, with the green, the yellow, and the blue, showing the buy loop centered on production, on the actual completion of stuff.
What exactly is active count?
It's the projects that have been funded but aren't completed. So it's like you got funds, but you haven't met your milestones yet.
The stuff in Giveth, basically.
Yeah, that's the stuff in Giveth.
Okay.
So here I renormalized it by the funds. So instead of count, and what you'll see is that because the system's accumulating funds, actually the size of the projects is growing. So the candidate went up a lot because later there's a lot of bigger proposals being made. They're just not passed, right? Because they have to be outstanding. Otherwise, they wouldn't be in candidate funds. But people are asking for more money at the end of the simulation. Cool. We've completed this many dollars worth or die worth of work, but where now we have new requests that are much bigger. But this happened because in this simulation, the successful completion gave rise to more funds, which gave rise to bigger proposals.
Yeah.
Cool.
And are you expecting these timestamps to be in days?
Yeah. So I set this up in days.
Okay, cool.
So it's at least logically in days.
Yeah.
And obviously, a lot of the processes can be retuned with timescales in mind. Just remember, this whole thing is pipes. So, a lot of the specifics of what you see are just a realization from a run that I ran. And we have a lot of control over the initial and the logics through which it evolves and the logics through which people make decisions. We just wanted to show as quickly as possible that the properties that we said the algorithm has in time, are actually the properties that it has. That as a demonstration. And so this is just conviction. It's not too informative. It's kind of squiggly. I made the chart that you had asked for. So this is the share of funds requested by proposal. You can see it going down largely because the funds are going up. But the specific plot that you and I had talked about was this one. So this is the conviction charging up to hit that hit the threshold. But I renormalized everything by dividing it by the threshold in order to show it kind of in a coherent way, right? Mm-hmm. I will note that this reason that these things have these shocks that go down off the chart is because they are being zeroed because they're being divided by infinity. So this is another way to look at that. That is the values without the log plot.
Cool. And each color is a different proposal?
Yeah, and in fact, I need to not. The other challenge here is that the colors cycle. So I had some notes in this to try to figure out how to get a different color palette because it like that it cycles through 1, 2, 3, 4, 5, 6, 7, like maybe 10 colors, and then cycles again. So like this, even weirdly enough, this orange and that orange are different, and so it's really hard to see because they're overlapping. The reason why they do that is because this orange one was one of the original proposals, and it was really big, so it took a really long time to pass. And then a new one that was the like 11th or 12th or whatever that comes up. So I definitely think that like managing from a like long-term perspective, there's just like stupid plotting stuff to be sorted out to like make these things clear. But I'm gonna leave this at semi-log because I think it's better in log.
And what are these like anomalies? Like that first blue one and the green one and the red and the purple that just
I'll show you.
above that.
So they're go ahead.
It's a 7-day thing where like that none of them can pass until 7 days. So they start out with someone just being like, I want this, and then maybe it's a small proposal that doesn't take much conviction, and then
it's much easier to see on this one. So in this one I rescaled it. So on this one it was time. In this one it's age. So the x-axis switched from natural time to renormalize so that each proposal's time starts when it was born, and now you can see this cluster. That's what you're talking about. They're the ones that passed on their 7th day.
Gotcha.
But you can also see that this green one here was it took the entire simulation to pass, basically. If it started in the beginning because there's only 200 days in this simulation. So it had to, in order for it to line up from there to there, it means that it literally was one of the day 0 proposals, and it doesn't pass till the end.
And I'm guessing that it couldn't even pass like for a long time. It was too big or something.
Yeah, that's why it doesn't show up until 125, even though that's age, right? This is age, and it was already 125 days in before the system even had enough funds to entertain passing it. Yeah. It may have had conviction, but these zeros are the divide by infinity makes the share of the trigger 0.
Yeah.
Is there somewhere we can look at the parameters of that curve of that proposal specifically, like the amount funds requested or anything like that?
Yes.
We don't have to this second. We don't.
Yeah, absolutely. So all that data is preserved. So what I was saying is that behind the scenes, this is essentially a graph database in state. So when this thing that I did all this mess here was to generate this plot, which is the thing I made the video from, and I used that data to make this. These are sized by the funds. These are sized by the funds requested, and these are sized by holdings. I might want to renormalize that so like I could scale up the size of these were, when I first did it, they were really overlapping. You know, I could talk to DataViz people and sort of clean these up and even make like a histogram that points to the left or something if you got like a really high-end DataViz guy. But like basically this is the size of the holdings of the participant, and so this is the 120 odd participants. The lines are their voting weights, and the reason why there was a video is because essentially it's just these images down here over time. So this was time slot 0 is this little tiny proposal. It's being supported by a lot of people, but it takes till the 7th day to pass, and there's not that much funds at the beginning, so you know, you just see that charge up, and then it turns yellow because it passed. But you'll also notice that the lines start changing too. So those are what people are voting for. And I mean, it's easier to see in the video. This is 200 screenshots basically that I used to make the video. But later on, you can start to see things like this happening. So like this graph is changing in time. I'm showing you the edges only for the votes and only with the weight of the votes. So the really light colored lines are people who are supporting something, but they don't have as many tokens, so it's not as strong of a support.
Right.
And the numbers are the convictions charging up, so you can sort of see the progress of You can see that one was one of the ones that came in hot, right? It started off like it didn't even exist, and it came right in at 100 and what? Yeah, comes in at 122, and like at the 7th slot, fast.
Got up to 257.
Right, but I mean, and this thing just keeps going. This is what's in the video, and I can make them again relatively easily. The hardest thing is it would be really nice if I had somebody with a little more experience who could directly make the video, because I hacked it. I just downloaded all the pictures and put them in an iMovie. I know that there's a way to do it in Python that's not too hard, but I started reading about it and I just didn't have the time. Like, it's just not my area.
You know whose area it is? Kai.
Cool.
Kai is a professional film producer. That's what he did for this.
Well, I would love to chat with him at some point, because I can make things like this pretty quickly, but it's less about the film. I mean, it's more. I was thinking more in terms of the programming, because I was looking it up, and you can do you don't need to do like iMovie. You can literally write the right block of code, and then instead of dropping these, it will compile them into a video. I did a really hacky thing where I printed them out, saved them using a line of code that saves them to disk, and then I took the files and loaded them into a video. But you can do all of that in line. It was with this like animation stuff that I don't really know how to use. Anyway, so that's the model that I created so far. I'm gonna show you quickly one other thing before I. Oh God! Stop it! How do I?
On the bottom. Yeah, there it is.
Cool. So I wanted to show this other screen quickly. So this is probably going to be in Abby's article, but this is a rough hack of a drawing, not a final drawing. I don't know if she's going to use it, but this is really important. In fact, every aspect of what we're doing boils down to recognizing that actually the thing driving these systems is the real value produced. And the real value produced, the real work, the milestones, the stuff being done by the people, which isn't really the DAO itself, it's the people using the commons. They get funds from one side, and then they get decision-making from the other. So like funds flow in through the funding pool, and while the proposals are being, sorting those funds, intuitively, you can think of this like a labor and a capital being on the same page, because the decision-making loop is the thing, the decentralized governance side, the green drawing here. This is where you can think of it as the token. It's the community deciding what to do and the funding that's required to do it. So you have the sort of capital coming in from the right and the labor from the left saying, here's what we're going to do. And then the yellow bar is actually doing it, and it produces outputs. And in our system, that output resolves to valuable outputs that result in future funding and tokens which represent future influence. Now, the fact that you can cash green into blue actually comes out of focus. It's necessary from a overall perspective, but it's not the salient feature of this. What matters is that in order for the system to be, living and breathing and doing what we want, it's actually primarily centered on the actual work being done. And it's only the fact that that's happening that leads to people caring about having tokens for future decision making, and people actually caring enough to put funds in. So, and that's inherently outside of the automation of a smart contract. It has to do with what people do given what they did. So that's this right side of this drawing. And I think that it's really important to remember that all of this is just a sort of facilitator for this sort of production line, this like horizontal line from sort of milestones complete to material outputs. That's the actual purpose of this system, is to help these people coordinate to do this thing using these funds. So the yellow bar is actually the center. And this is one of the reasons why I criticize so strongly a lot of the things that are being done and discussed. Is not that I think that they're bad parts, but the whole system ends up like its nexus is the actual production. If that fails or is done poorly or is managed poorly or anything, it means that there won't be a continuous source of funds because it comes from people appreciating or paying for or granting the continued labor. And likewise, there'll be no demand for the tokens because the decision making over that is only valuable if the thing itself is valuable. And so you actually put yellow in the middle. And obviously, this drawing is not the same as the little one because this is more actually of a value flow spec. So it depends on how things actually fit together. So the drawing is clear. The actual stylized sort of what's happening is this. And conviction voting is essentially if you think of the bonding curve as just the boundary, then you can almost think of the bonding curve over here. I don't really know how to one-to-one this to the bonding curve, but I would say this is the conviction voting stuff. This is giveth. And if we're really talking about it in 3 components, I would say, maybe this maps to the augmented bonding curve because the augmented bonding curve has the funding pool. But all in all, the system is centered on the leverage is actually on the production itself, not on the token and not on the capital. Like you need those 2 things, but it's like those are inputs and outputs of this central pillar.
Cool. I like it. Looks like this has come a long way, this stuff on the cyber physical commons.
Yeah, these are all the notes. And I mean, to be clear, I'm also I've got regular meetings with people from Sherman's group, and I've talked to her some. That's one of the reasons I recommended her. I read her. I was one of the reviewers for the chapter on behavioral economics and mechanism design in her book. And I'm feeling really good about the knowledge and expertise that's coming from the more economic side, which is where you see the discussion of goods, for example, and what does it mean to have a commons owned good in the blockchain era. And that's kind of where I was pushing Abby on the cyber physical systems, because I still think there's a lot of ignorance about the parts of the system, like what did you produce, who owns it, and what does that mean to the people who would participate. And if you ignore that stuff, you really aren't closing the loop.
Right.
Okay, so I'm done. You need to talk about your article.
Yes, and one question for you, which was one of Griff's first comments in the article. Actually, let me share my screen here.
Cool. Yeah, I can unshare somehow. I got up to full speed. I don't know if you noticed. full Zargham speed.
Okay, here we go. So, so first question that we had was, what do we call it when we are allocating tokens to a proposal? We call it staking. I think you called it, I have some of your notes in here as well. This was, what user actions are available. And one of the things, stake a certain number of tokens in order to make a proposal for commons funding of a milestone. So, Griff kind of mentioned that stake implies locking to a lot of people in this audience.
So
is there
there's
a better
a huge difference between making a proposal and supporting a proposal. So I was arguing that the person who's proposing, this isn't a hard requirement, but I think it would be natural to make the party that's actually proposing locked. So if you want to be the person who's taking ownership of the proposal, because there's going to be this downstream notion, right, that the proposal gets funded and you're going to have an initiative. And there's a place for Griff to step in and talk about how Giveth can or should or does work. But ultimately, if the trigger valve releases funds to an initiative, some address and some person, some identity likely has stewardship over that proposal's completion. And so if you are the proposer of a particular proposal, I think you're in a different category than a supporter. And I was saying stake because I was imagining that staker was actually locked in. And if they wanted out, they would either need to get someone else to take ownership of that proposal, or they would have to take it down. That you can't have ownerless proposals. They have to belong to some community member who asserts that by staking.
Yeah, so there's proposing it to the DAO and proposing it to Giveth, which are 2 different. So there's the stake of getting it to show up in the voting interface, but then there's allocating your tokens and voting, basically.
Yeah.
And that's I guess you're calling it assert tokens.
Assert.
Yeah, I mean, express preferences, like we can play around with the words. There's a little bit of like a design freedom there. We know what it means technically. It means that you have an unrestricted right to basically take your balance and allocate it against your preferences, and that it will accumulate conviction for the proposal according to the conviction voting, and you can move it whenever you want, but the conviction will vary based on those movements. So you just spend it, and the system is going to, as part of that action, when it, it's going to be able to update itself to account for the different accumulation, right? So like it's going to discharge over time. It's not even going to take away conviction. It's just going to accumulate slower and thus potentially go down. Right, the capacitor discharging thing. I will say that there's going to be a step that's going to be really important, and it's on my to-do list to write up more about temporal states and smart contracts, because what I've been, I don't want to say fighting with, but like trying to make sure that people understand is like a consistent way to deal with time varying things. And I have some thoughts on sort of predicate state update logics that basically just say, whenever someone wants to transact on a contract, then whoever's the next actor bears, some cost of what I will call the predicate state update, which means certain amount of blocks have passed. Therefore, a state update happens prior to your action. And you can always check the predicate state update with an off-chain call by running that predicate state update function. But predicate state update just means the real state of the contract is the prior state. And whenever you go to act on it, anything that, quote, happened between the last state and now as a result of just time is resolved by a predicate state update. So you just basically have that function called at the head of everything.
Yeah, we do that for liquid pledging. We like normalize the pledge is what we call it. So
this is I'm even talking about it as a reference architecture thing too, though, at this point, because I've run into it a lot, and I have a pretty good sense of how to specify it as a generic methodology. So whenever you define things as systems, like in a systems engineering way, if they can be purely state dependent, or they can be state and time dependent. And in the blockchain systems, this time is blocks count, and you can make things that theoretically don't require you to dredge the state. Like if you write the algorithms well, you're not actually looking at the state over the time in between. Good algorithms will say, given the prior state and the predicate state, or given the prior state and the blocks passed, just compute the predicate state, then act and get that posterior state, which becomes the new prior state. And that, I won't belabor it here, but I think it's something that we can do even as like a simple Medium article in a month or two. That'll be actually pretty cool, because it's a systems engineering concept that helps map system designs into blockchains in a very generic way. And it's about like it's basically numerical analysis, and like it's a kind of on the boundary between computer science and systems engineering.
Cool.
Sorry. Rambling, but I see it as a recurring pain point in a particular place where people might challenge the designs. They'd be like totally. You can't do that. It has past state dependence. And I'll be like, aha, but we can. Yeah.
Cool. Well, it'll be good to dive more into that. That seems a little bit future box, or like, down the road.
It's going to come up pretty quickly in the Materium thing, actually. We'll probably end up talking about it next week.
Cool. Awesome. So with the last 12 minutes, maybe I'll just do a quick run through.
I'm so sorry.
The
I talked way too long.
No, this is perfect. And just go through some of the main points I was looking to cover, and maybe clarify a few of those, or drop a few, or add a few, whatever. So I'm looking to create pretty much a component explainer series, kind of like high level, taking the math into English, explaining the features and functionality rather than the math and the logic behind it. Okay. So yeah, this will be the conviction voting as a continuous decision-making alternative. A couple of alternative titles, biomimetic decision-making systems. Just kind of figuring out what the best angle to approach this is to get people excited about what we're doing. Continuous biomimetic.
How about thinking outside the time box? Sorry, it just popped into my head.
Cool. This is why we're
It's
here.
like thinking outside the box, but the key is we're thinking out, like we're getting rid of time-boxed voting.
Cool.
I don't know, but we can play around with it.
Great. Yeah, just ideas to batter around. So audience, general crypto
Or
audience
you can make
purpose.
that joke inside, whatever.
Yeah. High-level explanation of the purpose of conviction voting, the benefits over existing decision-making modules. I don't know if we need to say TCRs in particular, and time-based voting.
I try to
mechanisms.
avoid them. I think we're gonna have to end up having a whole nother discussion about TCRs and like ontologically correct framing of token curated registries, because frankly, I have a lot of opinions on that, and they're not as directly aligned with. I mean, conviction voting is a different kind of decision making. We'll just leave a pause and come back to TCRs because I think we can talk about them. Just I don't want to mix this in with it.
Sounds good. Okay, so high-level explanation of conviction voting. Ultimately, we are trying to order proposals. It's not really ordering. I know you mentioned that it's not a strict A versus B versus C, but it's trying to use continuous preference to order those proposals according to preference broadcast for members. How do we decide as a collective how to allocate funds, basically? The module sits between the bonding curve and the Giveth DApp, where approved proposals are funded. We want humans to remain in charge of the socio-technical systems we're bringing into existence. Humans are social sensors. Conviction is fusion or aggregation. I'll reference your paper here, of those inputs towards necessary proposals and system updates. Quick note here that it's not just strictly ordering proposals. Some of this will definitely be tweaked. I also had a note from you saying that this was kind of like machine learning with humans, unsupervised one versus all classifier, where the inputs or preferences expressed by community members.
Yeah,
I don't know if that's
closer
a little
to the
too deep.
TCR stuff. That was closer to the TCR stuff. I would say you'd be better off when you go to the not strictly ordering, talk about it like neurons firing. That's example with the A versus B. Yeah, so you can hold the TCR stuff for another discussion because that's the one where the classifier stuff is a little closer to that. In terms of here, though, what we're really saying is that it's being modeled like the trigger function is a neuron firing and the convictions building up are like action potentials, and we basically are getting that action potential from the humans, and then when the conditions are met, that neuron fires, and that's a continuous to discrete mapping, and that's something that is really what's happening ontologically, right? Human preferences are like continuous time varying messy things, but we need discrete concrete outputs. And so our neuron firing is a really good example of a system that has this sort of messy, noisy, continuous time varying thing that gets converted into a discrete event, like a discrete binary event, like this happened.
Right.
And so we're modeling the off something that has an ontological similarity in that it's sort of noisy and messy and varying, but we need a discrete event output.
Cool. So that was action potential, you called it?
Yeah. So the action potential is the input to into the neuron. Yeah. You really just like read about a neuron. If you read a little few blurbs, I think you'll get the analogy.
I do remember. I just wanted to confirm that was the correct terminology. Cool. So I was going to put in a quick paragraph on how this differs from what we do today. Now, maybe this is more of a TCR chat. I was just looking to go into kind of some of our, I mean, we don't actually have to say problems with TCRs. It could be problems with time-based voting systems in general.
I would say it's easier to compare. I would address the differences from time boxed voting and the challenges with things like the Aragon votes as the pain point, and then we could make a like 2 or 3 sentences like, hey, like there's also some relations to TCRs, but we're going to explore TCRs and biomimetic TCR alternatives in another article. And so, like, I think because we're going to have to just go into a lot more than we can handle here to properly address basically, I'm going to end up giving you a breakdown of what TCRs are, what they can and should be, and unfortunately, that's just a bunch more work.
Yeah,
like we've talked about it a few times, and that does have to do with machine learning. We'll probably end up with a reference example related to like logistic regressions, where we can sort of show the way that the TCR problem space is actually much closer to a machine learning problem where humans are the computation.
Right. So do my question then, if we take TCRs out of this and focused on time box voting and like the Aragon vote issues, et cetera, do all of these problems still apply? So we've got
vote buying is something we want to address. Last minute vote swings we would want to address. Voter apathy we would want to address. Awful UX. I don't know. What about these last ones? Time interval too long, arbitrary set. Look at that. Yeah. So the last couple seem like they're consequences of the first few. So I don't know. I mean, like you can adjust them, but I think you're going, if you go up, it's one. So vote buying. So vote buying becomes vote renting and becomes relatively inefficient compared to just getting the votes yourself, right? Because of the integrator, it becomes inefficient to. Yeah, you get the idea. The second one was what? Last minute vote swings are possible, but they're greatly reduced because the votes that have been there for a long time are worth a factor more. So if you go grab votes at the last second and try to apply them, they will be worth whatever one. We talked about the ratio of one vote now to forever. Remember?
Yeah.
So like essentially your votes at the last minute are base level votes, and the people who've been broadcasting get that multiplier that's accumulated from conviction.
But there is no last minute. That's a great thing.
Yeah, right. There is. Well, you could try to push it over the edge. So last minute is like, oh, it's getting close. Let me force it. But you still get less effect than the people who've been doing it all along. You're proportionally a much smaller fraction of the conviction.
Yep. Addressing voter apathy through incentivizing community members to vote by unlocking tokens according to the vesting period that funds flowing through the funding pool.
That's one thing. The other thing that I was going to say is that your preferences being broadcast is something that you can, and I guess it depends on the UX layer stuff, but like because you don't have to vote in at a fixed time box, essentially you can periodically just go check in, set your preferences, and walk away. And if you do that once a month, you're still actively participating. You are not being forced to pay attention constantly to find out whether or not there's something you should be voting on and missing it. So in a sense, the cognitive cost of participation is lower because if you check in on your own schedule, you're never going to get a situation where it's like, oh, hey, there's a vote in 2 weeks, and then you're like putting it on your calendar or whatever. You're actually just going, oh, cool, I like that one. Maybe I'll jigger my settings around, and then I don't have to pay attention to it again.
Yeah, and I also think that we need to talk about implementation details on this just a little bit, talking about implementing ERC 888 and being able to have constant, like if you get new tokens, your preferences are being allocated for those new tokens already, and it's sort of like
preferences are share of holdings. That's part of the reason that the assert can make sense, right? If your token, your time varying holdings are totally fine because your preferences are expressed as a share of your holdings.
Yeah, exactly.
So, and I mean, behind the scenes, we have to figure out how to make sure that there aren't rounding errors and stuff. But like, practically speaking, it'll be fine.
Yeah. And the other interesting thing is when proposals get passed that you can not only new tokens being allocated, but also when allocations are no longer valid, that they're removed and that's
also pretty straightforward, right? Because if your allocation is a weight, if you think of it as a weight, I have power 1, 2, 3, 4, 5 over the list of things I support, and then your actual percentages resolve to sort of what percent of your total weight you allocate for your tokens. Then all you're doing is popping the thing that passed out of that list.
Yeah,
and then the whole thing is just fine. Like, it's just like, okay, cool. Well, that thing that was a 5 passed. It's now not in the list. So when you do the expression, it still works again without having to change really anything.
Yeah, I'm definitely still wondering how to implement that, but yeah, I know I'm sure it's possible, but it's going to be fun.
It's going to go back to the whole predicates thing, unfortunately, because what's going to happen a lot of times, it's that people are, whenever anyone does anything, there's going to be this gas cost, which is part of the reason we need to be on the side, on the POA chain associated with updating the state. Because what's happening now is that anytime anyone does anything, you're going to have some state variables that aren't immediately like, they're like once removed that are going to get updated. Like, I suppose I send you some funds, like potentially I'm going to need to do, I mean, we guess we could figure out when it should and should actually trigger the predicate state update. But like, there's definitely going to be some interesting things in terms of how we track those sort of state evolutions and compute these things.
I mean, I really think of, I always think of kind of counterfactual implementations along this side, where it's kind of like you can know what can happen without it happening in the smart contract.
That's the same way the predicate logic thing essentially works. You're basically saying this hasn't happened, but everyone knows that in order for anything else to happen that depends on this, it will always be called. So you know the state, there's the real state, and then there's the predicate state, which is the state the system will be in before anything can happen.
Yeah, exactly. So it's like, okay, like this was the last time funds were spent. The contract state still is super old. But then it's like, oh, guess what? It looks like from our model's option, it says that this new proposal passed. So someone's got to push the button to send the money to the milestone. And then
I think we're broadly, because of the nature of this contract in this system, we're going to be broadly relying on. That's one of the reasons why I think we may actually want to take a time out to write something about predicate state logic, because what I'm describing is the general reusable concept formally for what you're talking about. It's something where you could prove that the system worked as intended, essentially mathematically, by showing that there's no thing that you can do that doesn't force computation of the predicate state that would violate that state.
What I would say is that I know that at Giveth, we already implement something similar in the DApp. And I was during this talk, I was cruising EIPs looking for something along these lines. I don't know that I see one, but I'm sure that in the counterfactual like crew, I mean, like I want to ask Jordy and I want to ask some counterfactual guy if they know of something, because I don't want to write this article when there's going to be some other article that we should have referenced.
I'm not talking about writing the article from the perspective of the implementation. I would be just as happy to cite the person who's done things that follow this pattern, but I'm talking about reference architectures, not so much about and there's a level of abstraction beyond anything that I've seen. There are cases of counterfactual type things, but there is a very sort of rigorous and formal statement that says you can always do the following thing. If you can ever sort of factor your logic in this way, you can always do this. And it handles a class of problems. So what I'm basically saying is we're going to run into this class of problems a lot. We know how to solve this class of problems by factoring it like this. And hey, by the way, we know this works because these other guys did a version of this here.
Yeah, we'll look at it. Sorry, Jeff. Keep going.
No. Good. Cool. So I guess for some of these do definitely fit into whale dominance is kind of vote buying or influence of cash on or wealth on the system. I just wanted to address some of the other, like these arbitrary lock periods, the multiple transactions. I guess that's not so much Aragon.
I'm going to have to jump onto another call. If you guys need to, I can do another session on this later in the afternoon. But my business team call is now, and I'm kind of, I can't really skip it.
I think we just...
Fair.
I think you could just start writing this article and then have them review it.
That works too. Let me know specifically though about plotting, because I will generate images. That code is on the conviction repo. If you flip through it and get a sense of what you want, then let me know. Oh my God, Fathom. It's just cleaners. They're here every week. Right. So basically, I expect to support you with some images, but I need to know what you want, what fits into your story. But I can also make suggestions after there's a draft. So I'll let you go. Cool. Thank you guys very much. Appreciate it.
Sounds good. Thanks, Steve.
So fun.
See you in a few. Hey, Griff.
Yeah.
Where would I find